another key point. Let me repeat what are all the things that I discussed till now. Key point number 1. Key point number 1. Factors which are of the form 2k, 2k plus 1, 3k, 3k plus 1. All these things we discussed. These key point 1. Key point 2. Key point 2. Divisible by 6. Divisible by 6 but not by 12. Divisible by 6 but not by 12. This kind of models which we discussed. Key point number 3. Key point number 3. Number of ways. Number of ways. All the problems we discussed. Odd into odd we discussed. Odd into even we discussed. Even into even we discussed. Even into even we discussed. How to find the integral solutions for x square minus y square equivalent to k we discussed. How to find the integral solution for x square plus y square equivalent to k we discussed. X power 4 minus y power 4 equivalent to k. These also we discussed the analogy. Key point number 3. And we also discussed a number system application in this kind of problems. In this kind of problems. I hope it is clear. Kindly reply in the live chat. Then I will go to key point 4, key point 5, key point 6. 3 more key points which we will discuss. Key point 1, 2, 3. Just listening to the class once might not help you, right? Today's class, these last 2 sessions, I will try to keep it tonight only so that tomorrow you can watch it. Tomorrow you can watch it. Tomorrow morning 7 a.m. I am going to start with highest powers. I am going to start with highest powers. Tomorrow morning 7 a.m. I am going to start with highest powers. Tomorrow 7 a.m., 6 p.m., 9:30 p.m. All the 3 classes are on highest powers. 7 a.m., 6 p.m., 9:30 p.m. Single day we will complete highest powers logic. Highest power logic. 7 a.m., 6 p.m. and 9:30 p.m. Key point 4. Please write down. Key point 4. Key point 3. It is clear. Key point 4. Key point 4. Please write down. Concept is factors which are co-prime to each other. 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 3-4 questions we will discuss. Pradeep, very important. Kindly pay attention to the class. Rambabu. Factors which are co-prime to each other. Question. How many distinct factors? How many distinct factors for 72? How many distinct factors? Charging bettese. Key point 6 తర్వాత తీసుకుంటా. How many distinct factors for 72 are co-prime to each other? How many distinct factors for 72 are co-prime to each other? How many distinct factors for 72 are co-prime to each other? How many distinct factors for 72 are co-prime to each other? Now, method 1. Method 1. The generic approach. The generic approach. Method 2. Method 2 is nothing but the derived approach. Method 2 will give you the answer fast. Method 2 is the derived approach. Method 1 is the generic approach. Method 2 is the derived approach. Suppose if I take 72. If I take 72. What are the factors of 72? Let me write down all the factors of 72. 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, 8 is a factor, 9 is a factor, 12 is a factor, 18 is a factor, 24 is a factor, 36 is a factor, 72 is a factor. These are all the factors which are factors of 72. Am I right? Am I right? 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72. This is step 1. This is step 1. Step 1. Write down all the factors. Step 2. Step 2. Now read the question. Question says, how many distinct factors? Underline these distinct. No two should be same. Factors for 72 are co-prime to each other. Are co-prime to each other. They are co-prime to each other. They are co-prime to each other. What do you mean by co-prime? Co-prime is nothing but HCF should be 1. HCF of A comma B should be 1. Then only A and B are said to be co-prime to each other. Two numbers are said to be co-prime if their HCF is 1. Two numbers are said to be co-prime if their HCF is 1. Now if you observe, 1 is co-prime with 2, 1 is co-prime with 3, 1 is co-prime with 72. 1 comma 1 cannot be taken. Why? Because the question is distinct. The question is distinct. So 1 comma 1 cannot be taken. 1 comma 1 cannot be taken. Totally, how many numbers are there which are co-prime to each other? 2, 3, 6, 9, 11. There are 11 numbers. There are 11 numbers which are co-prime with 1. Am I right? First step. How many numbers are co-prime with 1? Next step. How many numbers are co-prime with among each other? 1 with 2, 1 with 3, 1 with 72. There are 11 numbers. There are 11 numbers which are co-prime with 1. There are 11 numbers which are co-prime with 1. Am I right? Step number 3. Step number 3. 72 is nothing but 2 cube into 3 square. Total factors for 72 are, total factors for 72 is 4 into 3, 12. Total factors for 72 is 12. Factors which are co-prime with 1. Factors which are co-prime with 1, they are 11. Factors which are co-prime with 1, it is nothing but 11. Factors which are co-prime with 1, it is 11. Now, if you see, what are they? 1 comma 2, 1 comma 3, 1 comma 4, and so on up to 1 comma 72. Am I right? Next one. Factors which are co-prime among themselves. Factors which are co-prime among themselves. Co-prime among themselves. What is that? If you see, n is 2 power 3 into 3 square. This is 2 power 0, 2 power 1, 2 power 3. 3 power 0, 3 power 1, 3 power 2. 1 is taken out. 2 and 3 are co-prime to each other. 2 and 9 are co-prime to each other. 4 and 3 are co-prime to each other. 4 and 9 are co-prime to each other. 8 and 3. 8 and 3. 8 and 3 are co-prime to each other. 8 and 9 are co-prime to each other. Am I right? So, other than 1, remaining which all powers of 2 are co-prime with which all powers? All the powers. Everything with other is co-prime with each other. 2 with 3, 2 with 9. 4 with 3, 4 with 9, 8 with 3, 8 with 9. Totally what will be the answer? 6. So either factors which are co-prime with 1 is 11 or numbers which are co-prime among themselves is 6. 11 plus 6 is 17. 11 plus 6 is 17. How many factors for 72 are co-prime with each other? It is a two-step solution. Factors which are co-prime with 1 we have to take, otherwise eliminate the powers of 2. All the powers of a prime number with every other prime number powers. Prime number powers. 11 plus 6 is 17. This is a generic method. This is a generic method. Now we will optimize this method. This is a generic method. 2 with 3, 2 with 9, 4 with 3, 4 with 9, 8 with 3, 8 with 9, total 6. 11 plus 6 is 17. Now we will generalize it. I hope it is clear. Now we will generalize it and create a conclusion. Generalization. If I generalize it, n equivalent to P1 power A into P2 power B. Step 1. Total number of factors for this number. Total number of factors for n will be 0 to A plus 1, 0 to B plus 1. Step 1. Step 2. Factors which are co-prime with 1. Factors which are co-prime with 1. Factors which are co-prime with 1. 1 is co-prime with every other number. Because it is distinct, we should not do 1 with 1. All the other remaining numbers are A plus 1 into B plus 1 minus 1. Previous example you see 1 with 2, 1 with 3, 1 with 4, 1 with 72. Out of 12, 1 is co-prime with every other number. Every other number it is 11 we got. Step number 3. Step number 3. This is nothing but P1 power A. P1 power 1 into P1 power A. P2 power 1 into P2 power B. Every power of P1 is co-prime with every power of P2. So factors which are co-prime among each other. Factors which are co-prime with among each other. Factors which are co-prime among each other. It is nothing but A into B. So the total answer is A plus 1 into B plus 1 minus 1 plus AB. These AB plus A plus B plus 1 minus 1 plus AB. Answer is A plus B plus 2AB. What are AB? AB are nothing but the powers of the prime numbers. Please make a note of it. I hope the logic is clear. Why it should be A plus B plus 2AB. Why it should be A plus B plus 2AB. I hope the logic is clear to you. I hope the logic is clear to you. Mobile disko. Kindly ask me in case if you got a doubt in any of the logics. A plus 1 plus into B plus 1 minus 1, right, plus AB plus AB. I hope it is clear. Kindly reply if it is clear to you. Kindly reply if it is clear to you. A plus 1 into B plus 1 minus 1 plus AB. It is A plus B plus 2AB. A plus B plus 2AB. Write down a question. Abhay, I think you are new to my channel, right? When a topic is there, attention only on that topic. Sujata, you can purchase and watch the session 1 again. A plus B plus 2AB. A plus B plus 2AB. Total number of factors is A plus 1 into B plus 1. Factors which are co-prime with 1. 1 is co-prime with every other number. It is A plus 1 into B plus 1 minus 1. That is with 1. Other than 1, 1 is P1 power 0, P2 power 0. So P1 from 1 to A is co-prime with 1 to B, which is nothing but A into B. A plus 1 into B plus 1 minus 1 plus AB. Conclusion is A plus B plus 2AB. Please write down this point. Distinct factors for n equivalent to P1 power A into P2 power B, which are co-prime to each other, is given by the logic A plus B plus 2AB. A plus B plus 2AB. What are A and B? A and B are nothing but the powers of prime bases. A and B are nothing but the powers of prime bases. First we will do it for a 2 prime bases, then we will extend it to 3 prime bases, 4 prime bases. Harita, I am going to explain that one. I will not leave any concept in this one. I am sure you must be understood my style of teaching by now, in case if you have watched. Right? First we will do for 2, then we will extend it. Example, n equivalent to 2 power 4 into 3 square. Answer is nothing but A plus B plus 2AB. A plus B plus 2AB. 4 plus 2 is 6. 4 4s are 16. 16 plus 6 is 22. 16 plus 6 is 22. Suppose if it is 3 prime bases, 2 cube into 3 square into 5 power 4. 2 cube into 3 square into 5 power 4. Apply the rule of recursion. Take any 2. Get the answer. Do it with the third one. If I take these 2. Factors which are co-prime with 2 and 3. A plus B plus 2AB. A plus B plus 2AB, which I got 17 here. K power 17 into 5 power 4. What is this K? K is nothing but a set which are co-prime with 2 and 3. Again answer is A plus B plus 2AB. A plus B plus 2AB. 21 plus 68 2s are 136. Answer is 157. Take with any 2 and do it with the third one. You can take 2 power 3, 5 power 4, then do it with 3 power 2. Still the answer will be same. I hope Balaji you understood the point. For 2 numbers we will develop this and then we will extend it to any numbers. 2 power 3 into 3 square. A plus B plus 2AB. 17, which is K power 17 into 5 power 4, which is A plus B plus 2AB. One more example. N equivalent to 3 square into 5 cube into 7 power 4 into 11 square. Factors for n which are co-prime with each other. Factors for n which are co-prime with each other. Factors for n which are co-prime with each other. Answer for this question is take first and second, third and fourth. 2 plus 3 plus 2 into 2 into 3. 4 plus 2 plus 2 into 4 into 2. 2 plus 3 is 5. 5 plus 12, 17. 4 plus 2 is 6. 6 plus 16 is 22. So this is a power 17 into b power 22. Again the answer is a plus b plus 2ab. 2 into 17 into 22. These are the 17 values which are co-prime with each other. I am writing it as a power 17. A and b are not prime numbers. A is that set which are co-prime among 3 and 5. B is that set which are co-prime among 7 and 11. Co-prime among 3 and 5, co-prime among 7 and 11. From this answer is 17 plus 22 plus 2 into 17 into 22. 2 into 17 into 22. Numbers which are factors which are co-prime to each other. Next one, key point number 5. Key point number 5. First concept, key point number 5. Suppose if I take an example, 15 is there. 15 is 1 plus 2 plus 3 plus 4 plus 5. 9 plus 3, 12, 14, 15. It is also 7 plus 8. It is also 4 plus 5 plus 6. 15 is nothing but 3 into 5. Please write down this point. I will discuss the proof in day after tomorrow, factors and multiples cat level. There I will discuss number of ways of writing a number. Number of ways of writing a number as a sum of 2 or more, as a sum of 2 or more consecutive positive integers is given by total number of odd factors minus 1. Please write down total number of odd factors minus 1. Number of ways of writing a number. Number of ways of writing a number as a sum of 2 or more consecutive positive integers is total number of odd factors minus 1. Total number of odd factors minus 1. Right? Banu is telling total number of factors less than or greater than the factors which are co-prime to each other. I did not understood your line. Abhay, yes, it is total number of odd factors minus 1. If it is 1 or more, it is nothing but total number of odd factors. Total number of odd factors. Why? Right now only I will give the proof. Why to wait for day after tomorrow? Number of ways of writing a number as a sum of 2 or more consecutive positive integers is total number of odd factors minus 1. 1 or more will be total number of odd factors. This is, I took it as an example. Now I will discuss the proof. Please write down proof. Please write down proof. Please write down proof. Please write down proof. Proof. Right, let the numbers are a plus 1, a plus 2 and so on up to a plus n. Let there are consecutive natural numbers from not from 1 to n. A could be 0, a could be any value. Now if you see Sn is n by 2 into first term plus last term. First term plus last term. N by 2 into first term is a plus 1. Second term, last term is a plus n. So this is nothing but n into 2a plus n plus 1. If I take the number as example 15, this is nothing but 2 15s are 30. Through 15s are 30. I hope it is clear. It is 2 into a into n plus 1. Now if you see, if n is an even number, 2a is an even number. I hope it is clear, right? N by 2 into first term to last term a plus 1 to a plus n. N by 2. N by 2 into first term is a plus 1, last term is a plus n. So n into 2a plus n plus 1 equivalent to 30. Just by looking at the question, we can say that 2a plus n plus 1 is greater than n. If n is even, this is even. Even plus 1. Even plus 1 is odd. If n is even, this number will be odd. If n is odd, this is odd. Odd plus 1, even. Any number multiplied by 2, it is even. Even plus even is even. That means either it is becoming even into odd, or it is becoming odd into even. Already we discussed. In an unordered pair, number of ways of writing a number as a product of odd into even is nothing but number of odd factors. One or more consecutive positive integers, it is a number of odd factors. I hope the proof is clear. N into 2a plus n plus 1 is 30. If n is even, even plus 1 is odd. Any number multiplied by 2 even. Even plus odd is odd. So this is even into odd. If n is odd, odd plus 1 is even. Even plus even is even. In how many ways can you write a number as a product of odd into even? It is nothing but number of odd factors. It is nothing but number of odd factors. One or more. Two or more means that one case we have to eliminate. That one case we have to eliminate. So answer is number of odd factors. Number of odd factors. Please write down a question. Please write down a question. Question. In how many ways? Question. In how many ways can 2004? In how many ways, or 2001 we will take. In how many ways can 2001 be written as a sum of two or more consecutive positive integers. Two or more consecutive positive integers. In how many ways can 2001 be written as sum of two or more consecutive positive integers? 2001 is 3 into 667. 3 into 29 into 23. Number of odd factors minus 1. Number of odd factors minus 1. So 8 minus 1 is 7. Number of odd factors minus 1. So answer is 8 minus 1, 7. 8 minus 1, 7. I hope the idea is clear. 8 minus 1, it is 7. Number of ways of writing a number as a sum of two or more consecutive positive integers is number of odd factors minus 1. Right? Now for today we will wind up the session here. I will have my dinner